Today, we are going to create a function to validate if a given number is prime. A prime number has only two divisors, the unit and the number itself. We are going to create the function is prime. We define a parameter. We can call it number. Good. Now, inside the implementation of this function, we create a function called divisors, and we initialize it with 0. At the start of the function, we don't know if how many divisors has this number. Now, in a for loop, we iterate from 1 to that number for e in range from 1 to number plus 1 to include that number in the range. Okay. Inside this for loop, we verify if number modulus I is equal to 0. With that, we are saying if the current value of the iteration variable I is a divisor of the given number. If that is true, we increase the divisor variables in one unit. We have another divisor, so we increment that variable in 1. Finally, we return the evaluation of this Boolean expression. Divisors is equal to 2 is equal to the number 2. If divisors has exactly 2 divisors, we have a prime number. We can test this function. We call it prime. Pass, for example, 5. 5 is prime number, so we get true. Execute, and that is the value that we get. Great. And now we can test this function with another value. For example, we can call its prime function with 10. 10 is not a prime number because it has various divisors: 1, 2, 5, and 10. 4 divisors. It is not prime. We get false. Great. Another test. For example, here we can call its prime function with 43. That number is prime. It only has 2 divisors, 1 and 43. Execute, and we get true in this output. Great.